Hello and welcome. We'll be taking a look at the worksheet that is dealing with vertical and horizontal parabolas in vertex form as well as in the conic form equation. So the first distinction you want to make is, will my parabola be vertical or horizontal? Okay, so for the parabola to be vertical, you would be dealing with x squared, which is not really a surprise because this is what you've been dealing with all along, right? So if you say y equals x squared, that would be your parent function of a quadratic function. So notice here, what is raised to the power of 2? X minus h is raised to the power of 2. That means you would have x squared. And that's how you know the parabola is vertical. Now, is it going to open up or down? That will depend on your a, okay, which is the coefficient in front of your x squared technically. And if it's positive, it's opening up. If it's negative, then the parabola would be pointing down. Now, what you need to talk about here is this. You're talking about the focus, you're talking about the vertex, and you're talking about the directrix, okay? In a previous lesson, you've also learned what a focus is versus what the directrix is. So P, which is here, this segment here, which is the distance between the vertex and the focus, will be the same as the distance between the vertex and the directrix. So you want to make sure that it's always on your mind, okay? Because for different decision making purposes, you want to remember that that's the case. So now, another thing I wanted to point out right away before we look at anything else is this. Your A, when written in a conic form equation, your A becomes your 4P, okay? Conic form equation for the vertex form, you see that? Where you have x minus h squared on one side and everything else on the other. Your 4P is basically that coefficient we're talking about. Now, whatever number that is, if you take half of it, guys, let me tell you, if you take half of it, then this distance from the focus to the actual point on a parabola will be exactly that. So half of your 4P is going to be that distance. And of course, because it's equidistant, since we are talking about, a symmetry across the axis of symmetry, that distance will also be the same both ways, which means you can always find a point, okay, a point on the parabola to place in addition to say, oh, okay, fine. If I know what distance to go by, I can place those additional points as I graph my parabola. Okay, so let's look at what is given. It says, identify the key attributes from the given equations and the graph. Now, you're not just going to produce some cheap graph. It has to hit those critical points so that you can do a decent job. So please go back to what we just discussed to make sure you take advantage of that knowledge. I try to show you what that means. Okay, so let's highlight that again to make sure you understand what it is you want to pay attention to and how to use that information. You can do additional work, which I also am showing you to refresh your memory on how it's done. But most importantly, I want you to make wise decisions. Okay, working hard is good. Sometimes working smart is better. So let's try that. Let's see what's given. The equation shows x squared. Okay, what does it tell me? X squared. It's either opening up or down. Okay, so the parabola will be either pointing up or down. It's not going to be a sideways one. At least that much I know. Now I also know I want to write it in a form where I can read the vertex. Okay, so I go back to this form right here. I fill in what I know, and so happens my vertex is 0, 0. That's my first critical point that I'm going to plot, and I do that. And then I investigate what else is going on. Okay, within my function here, oh, 12. How did I even get that? It was given to me, so that was not hard. What I do need to connect to is that the 12 represents my 4p. And if I know that, then I can also figure out that p must be 3. Okay, so I fill that in. Okay, so my 4p is 12, therefore p is 3. Why? Because 12 divided by 4 is 3. So how does that help me? What do I do with p again? Well, p is the distance from the vertex to your focus, but also from the vertex to your directrix. And that's what you need it for. You also know once you have your f, you can do the sideways jumps to place additional points on your graph. So what's going to be my sideways jump? I start with 12, right? So that's my 4p. What's half of that? Oh, that's 6. So that's going to be my sideways move by 6 to the left of my focus and by 6 to the right of my focus. And it will give me 2 additional points. And now I can actually do a pretty decent job. Notice that this parabola, what does it have to do, or what does it have in common with my parent function? Well, the parent function would be y plus x squared. The only thing that's different here is the width, right? Okay, the width. Notice that technically it would be 1/12 x squared. So is it going to be wider or narrower than the parent function? You got it, definitely wider. Now, here's what I did on the side when I said, don't work hard, work smart. You can always find the intercepts to guide you further, right? And that's how it's done. You can take a look at that, refresh your memory. But do you really need that? If you know how to do what we just discussed from the focus sideways movement, depending on the type of parabola, of course, it could be up and down movement too for the horizontal kind. But if you know how to use those distances, you're good to go. You can basically skip all of this if you can do the shortcut. But it's good to kind of refresh your memory on how to find the intercepts. Okay, so let's go to the second equation and investigate what's happening. Okay, so where's my marker? Hello, disappeared to my other screen. Here we go. Look at that. Do I have x squared or do I have y squared? That's the first thing to decide on. I have x squared. Oh yeah, it says -4. What does that tell me? Oh, parabola is pointing down. Ding ding. Unlike on the first one, it was pointing up. So those predictions you want to make right away. And you're like, well, can't I just go to, into my calculator and put that in? Okay, you can try that. If you go to y equals, okay, if you go to y equals on your TI-84, your y is already there. Now what you're going to do? You can use the Desmos calculator to do it. Okay, so that's how you can circumvent it. I would definitely kind of, use it as an additional tool, but it's not going to replace what you need to know. So -4 is pointing down. What are my critical points? Notice that the opposite of what's happening, x minus 3, into my vertex, a positive 3 moves in. Y minus 2 into my vertex, my positive 2 moves in, x comma y. So I got my vertex. I place my vertex first, okay? Then what do? I go back to the idea of -4 must be my 4p, all right? My 4p is -4, boom. And now I want p. Isolate p, that means -4 divided by 4. You got it, -1. And then you're like, well, so what does that mean? -1 simply tells you you're going down, okay? And your focus, notice, unlike in the first problem, your focus is now below the vertex. And your directrix is above the vertex. Okay, so what's the directrix anyway? The directrix is a horizontal line that we are kind of measuring things on, and it serves for the equidistant idea, okay, to the graph and to the focus. Anyway, got that. What else do I need? Got my directrix. Oh yeah, axis of symmetry. How do I know that? My axis of symmetry will go through the x value of the vertex. So if I know my x value of the vertex, which I do know, I know it's the x value. So x equals 3 would be my axis of symmetry. So there we go. Bing, ding, ding. And not perfect. You get the idea. Okay, so that would be your mirror line. Hopefully that helped with this section. Now we're looking at the horizontal parabola. How is that different? Okay, please take a good look at the actual vertex form versus the conic form. What changed? I'm going to give you a minute to think about it. What changed? Okay, hopefully you got it. What changed was I now have the y that's being squared. Check it out. In my conic form, ding, 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 my y is now to the power of 2. How do I put that in the calculator? Yeah, how do you? I wish you luck. That's why you want to know how to do that without the calculator too, okay? So now what happens is your parabola will be either opening to the side to the left or to the side to the right. Okay, when does it open to the left? When we have a negative a, and to the right when you have a positive kind. Here you go. Okay, now let's take a look at the actual example. What's happening? And again, you may be like, well, how do I know how wide to make it? Please do not rely on the vertex as your only point and come up with some sort of parabola, or even worse, some pointy something. Okay, so don't do that. Do it nicely with a smooth curve so that you can show how well you understand what a parabola actually is. Check it out. Okay, prediction. First, we're making a prediction. Y is raised to the power of 2, so that makes it a horizontal parabola. My number in front of x is actually negative, so it's going to point to the left. Okay, so we're going to the left, opening to the left. Notice that once I have my directrix, yeah, how do I get my directrix? Did you forget? First of all, back to the vertex, okay? Start with that. You can't see the vertex unless you have it in this form, and then you're like, oh yeah, it's 0, 0, boom. So you start with that. Then you take that next step and you investigate your -8 right here. That becomes your 4p, remember? And how do you get p isolated? Obviously divide by 4. And that's what you get. Now, your p is the distance. Now you see how it's -2? It's opening to the left. I have no idea why this is pointing down. I don't know why it's there. It's gonna point to the left. Ding, ding. And 2 steps. Watch. From the vertex to the focus, 2 steps. From the vertex to the directrix, 2 steps. And now what else do I want? I want to know how wide to make the parabola. How do I get there? Okay. Well, let's just graph the directrix. Why not? There it is. The directrix is right here. And my axis of symmetry. This time, the axis of symmetry is going to be a horizontal line. Okay. It's a horizontal line and it's going through the vertex. Now, what was my vertex again? 0, 0. So therefore, it's y equals 0. Boom, you got it. So back to the points now. How do I decide how wide to make my parabola? All right, so you go to the -8. You take half of it. That's 4. Okay, let's see. 4 steps to, this time it's not left and right. It's up and down from the focus. Ding, 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 ding. Okay, so 4 steps up, 4 steps down. And now I know how to make my parabola nice and wide. And then you're like, well, can I, can I do intercepts? Which ones would you like? Because the only intercept you have at this point is the 0, 0 for this particular function. True or false? Okay, so that means the intercept idea, as we have applied in certain other problems, right here wouldn't suffice. Could you pick additional points, like some other random points that might be on the graph? Well, please don't put any points that go this way. Why? Because the parabola is not going to cross your directrix ever, in fact. Okay, so don't do that. Do what makes sense. The parabola will be pointing away from the directrix. So as long as you choose points that are like this, the input could be a negative something, something. Yeah, you could do that and place additional points on the graph. It doesn't make it any easier than working with half of your 4p. I suggest you consider. So what else? On the other one. Okay, so the example on the right, what's happening? We have a y that is raised to the power of 2. So y squared makes it what kind of parabola? A horizontal kind. And which way are we opening up? Well, it depends on the number in front of this guy. 16 is positive. Therefore, we are opening to the right. Now, what do I do? What do I do? Oh, yeah, the vertex. I start with the vertex, the opposite of whatever it seems to be every time. So instead of +4, as it appears to be, because it's accompanied by x plus 4, it's going to be -4. And then it's going to be a positive 2. Plot. Ding, ding, ding. The vertex first. Then we're going to do the focus. Okay, but how? Okay, how? Go back to 4p. What is it? The 16 was 4p. Divide by 4. It's going to give you the p-value, which is the distance. So this is where the 4 came in, 4. Now you may be like, but how do I know which one is the directrix, which one is the focus? Well, haven't you decided that your parabola is going to point this way? Okay, the focus will always be inside of your parabola. Boom. Okay, so that's going to be your focus. The directrix will be on the outside of the parabola, the same distance away as your focus, same distance from the vertex. Okay, so therefore you already know which way. So that's how you know the focus. And then you just simply, read the coordinates once you've plotted that. Boom. Well, of course, you can consider the vertex. The vertex is a -4, 2. Okay, now 4 steps, your x value is changing by +4. It takes you to 0, 2. Even if you didn't have a graph, you could still do that. Just a little bit harder to do mentally. Okay, so what about my directrix? How did I get that again? Same idea. So if my x value of the vertex is -4, I'm going to the left by 4. Okay, so that makes it -8. Boom. You can read it off the graph if you have the grid. Now the axis of symmetry, what's that? That goes through the vertex and it is going to be a horizontal kind. Therefore, I'm considering my y value of the vertex, which is 2. Y equals 2 is the correct choice. Now, can I now work with intercepts? Yeah, I could. Which axis am I interested in? The y-axis. Do I really want to do that? Not really. I really don't want to do it at all. It would be much smarter to go back to my 16, take half of it, go back to my focus and do ding, 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 8 steps up, 8 steps down. And so happens you actually get the same as this because the focus was on the y-axis. That was kind of fun. Aren't you happy? Okay. What's happening here? This time they give you the vertex, they give you the focus. They want P, they want the equation. What are you gonna do? What you gonna do when they come for you? Okay, here you go. Well, plot the vertex. That's what I would do. Plot what you know. Plot the focus. Count your steps. Okay, that will be your P, isn't it? That's your P. P, P, P. That's P. That's what they wanted to know. Okay, that's how I got it. And I know that from the vertex to the directrix will be the same P. Do they even want the directrix? Do I need it? I don't know. I do know I need the number in front of my x parentheses. So how do I get that? Now you're kind of working backwards, right? You know P, you know that you want to get your 32 now because 4 times P is 32. And then you're ready for the equation because the vertex, remember to put the x where it belongs. So you kind of need to know the general form, okay? Oh yeah, now you may be like, well, but how did you even know that it's going to be horizontal? Okay, just by looking at the vertex and the focus, could I have predicted that my parabola is horizontal? Well, I must. Look what repeats, the y value, right? So that means your this thing, volume, hello, vertex and focus will be along the y-axis. What am I saying? The vertex and focus will be along the horizontal line through 6. Okay, that's how you know it's a horizontal parabola. Anyway, do you really want to do the intercepts? Once again, do you? If you like it, go for it. If you don't, just know that you need 16 steps, really, right? Half of 32. to determine the width. So similarly, here you can tell what repeats, the y value repeats, ding, ding, through -2. So I already know what's going on here. Okay. And you also know that the focus is inside the parabola. Therefore, the directrix is the other way. And this is the equation of. You got it. So it is definitely good to know this information, guys. This information, the conic form. So refer to that. The conic form for the horizontal versus the conic form for the vertical. You should have that written down somewhere to refer to. So hopefully that helped. And here it is in summary. What do you want to check for? Check to see if you are dealing with x squared or y squared, and then whatever else is around it, who cares? It's about, is it going to be a vertical parabola in case of x squared, or is it going to be a horizontal kind in case you're dealing with y squared? Now, P is the distance between the vertex and the focus. It is also the distance between the vertex and the directrix. Those distances are the same. The parabola will point away from the directrix, always. I hope you had a great time discovering all these wonderful things. And these are the other two examples that you had where the parabola is a vertical kind. So if you need additional explanations, the idea is the same. This time, always start whenever you can, you start with the vertex, okay? Well, for this example, the vertex was not given. So they gave you the directrix. Now you're relying on your knowledge. What do you know about the focus and directrix? Now, the distance between the two of them will be what? To the vertex? The same. So that means right now the distance is twice as long. So if I divided by 2, I would know what the vertex would be. Okay, and I did that. So my P is actually -2. Okay, -2 because it's pointing down. And now I know how to locate the vertex. Okay, there it is. And once I know that it's a vertical parabola, I know that x squared. Okay, in the first set of parentheses, I'm going to have the x and to the power of 2. And oh yeah, how did I know to put -8? -2 times 4. Boom. And then I just place my vertex in accordingly. Okay, x turns into its opposite, and so does y. Okay, on the last one, you have the vertex given. Start with that. The directrix is over here. Ding, ding, through 1. And now what are we going to do? You count. Okay, your P. You count your P. That's 3. And 3 up gives me the focus. And now x minus 5, y minus 4. I knew it's going to be x squared because of the situation with the your focus inside of your parabola, and parabola needing to point away from the directrix. So now what? How do I get that? 4p. Remember, I need 4p. And 4p is exactly 12. Congratulations. I am sure you'll do a great job and submit your notes.